Hello guys, so welcome back. Today we're going to talk about surge protection. Another concern in many control circuits is the voltage spikes or surges produced by collapsing magnetic fields when power to the coil or the relay or contactors are turned off. These collapsing magnetic fields can introduce voltage spikes that are hundreds of volts. As you can see in image 1-11, diodes can be used to suppress the voltage spikes produced by coils that operate on direct current. Diode is connected in reversed bias to the voltage connected to the coil. During normal operation, the diode blocks the flow of current, permitting all the circuit current to flow through the coil. When the power is disconnected, the magnetic field around the coil collapses and induces a voltage spike into the coil. Because this induced voltage is opposite in polarity to the applied voltage, as stated in Lenz's law, the induced voltage causes the diode to become forward biased. A silicon diode exhibits a forward bias drop of approximately 0.7 volts. This limits the induced voltage to a value of 0.7 volts. The energy of the voltage spike is then dissipated as heat by the diode. Image 1-8 shows these high voltage surges can damage electronic components connected to the power line. Voltage spikes are of the greatest concern in control systems that employ computer control devices such as programmable logic controllers and measuring instruments used to sense temperature, such as flow sensors, pressure, and so on. Coils connected to the alternating current often have a metal oxide varistor MOV connected across the coil. Metal oxide varistors are voltage-sensitive resistors. They have the ability to change their resistance value in accord with the amount of voltage applied to them. The MOV has a voltage rating greater than that of the coil it is connected across. An MOV connected across a coil intended to operate at 120 volts, for example, has a rating of about 140 volts. As long as the voltage applied to the MOV is below its voltage rating, it exhibits an extremely high amount of resistance, generally several million ohms. The current flow through the MOV is called leakage current, and it is so small that it does not affect the operation of the circuit. If the voltage across the coil should become greater than the voltage rating of the MOV, the resistance of the MOV suddenly changes to a very low value, generally in the range of 2 to 3 ohms. This effectively shorts circuits the coil and prevents the voltage from becoming any higher than the voltage rating of the MOV. In image 1-10, metal oxide varistors change resistance value very quickly, generally in the range of 3 to 10 nanoseconds. When the circuit voltage drops below the voltage rating of the MOV, it returns to its high resistance value. The energy of the voltage spike is dissipated as heat by the MOV. Thank you for watching, and if you like my videos, please consider giving me a like. Feel free to comment, share, and I will see you in the next one. Thank you.